You can go to, just go to a pet store. These are $8.95 or maybe $11.95. They're pet urine detectors. Or if you want to go to BioQuip, the wavelength on these is 395 nanometers. So when I first did this, I had this spy pen that was the exact right wavelength. I ordered black lights on the web, and I'd get them in and put them on, and they wouldn't work because they were the wrong wavelength. It's got to be right around 395. I mean, this is what I bought 4 UV things that did not work before I finally realized. I went to BioQuip and I'm like, I need 395, bam, get it. The ones at the pet stores are this wavelength too.
I think I got 3 delivered for like $30.
Yeah. Yeah, so anyway, at some point in time when we do the more of the adelgid stuff, okay, now what I'm going to do here is I just want to walk through this real quick and tell you guys about.
Well, I want to check and see if people are into it, because we have a nice infection of adelgids.
Okay.
On the property. It's a little bit of a walk, and I wonder if people want to do that once it's dark enough to go out there. Will we see anything if we don't have? We will have some natural predation anyways, right?
Right. Should I do slideshow on this? Or will it?
You want to do that?
Well,
Or you just want to advance it?
well, yeah, I just want to advance it. See, it's not doing it.
I'll just have a static shot, and then you tell me advance, and then I will advance for you.
Okay.
Just say go.
All right, so go. Boom. See if it'll do it.
I think it's easier to click.
Huh?
Click outside the box,
Yeah, I had it going a second ago.
but it's highlighted. There you go.
Yeah.
Yeah.
There we go. Okay, now this is a dated PowerPoint, but the main point is you guys know that here's your hemlock distribution. It goes all the way out here. It also, there's a couple outliers in my home state of Missouri. There's a county, McDonald County down here, that has naturalized hemlock populations. So what happened over time when the continent was cooler, these hemlocks went all the way here, and what's been happening is they've been slowly retreating north as the climate gets warmer. And so in 1950 in Richmond, Virginia, some people brought in weeping hemlocks from Japan that had this adelgid, okay? The adelgid is also native to our own country. Go to the next slide, all right? So it was first identified in the 50s, about 54. It's been really, cranking along at, nearly 10 miles a year. It's expanding exponentially. So over half the hemlock range. For those of you, here is an electron micrograph of an adelgid. It's basically an aphid, and it's burgundy colored. It looks like a wine. It's that dark red color. Right now, they've broken diapause, and you have second instars, so they're puffing up with this little, with your wool there, okay? Yes, when you get, okay, now here's where I did the who, what, when, where, why, and how that nobody had done in the Forest Service. What level of these adelgids hurts a tree and what level doesn't? Because all they were thinking about was either in absolute terms, either a tree had all these or they wanted nothing. And I'm like, I'm going back to our farmscaping stuff, right? So now I'm dropped into a group of foresters, and they think that I am a lunatic. So I'm right back in where I was with the North Carolina Department of Agriculture in a way, at least at first, okay? And so these feed at the base of the needles. When you get more than 45% of the needles on a tree infested, the respiration drops to 5%. So there's our threshold. All we got to do is drop the number of adelgids on the tree below 45%, and if the predators are there, they will do this, okay? So here's what started to happen. I started going to Seattle as part of dissertation. I was on the PhD committee of a guy named David Mauzell that did all the original releases on this, and I wanted to get involved in this, so I asked to be put on his committee, and they foolishly put me on the committee, all right? So the next thing I did was call Dave up and say, I'm not your average committee member. I said, think of something that I can do to help you, and I will do it. So he called me back and he said, how about going to Seattle with me and collecting these bugs? That was the best thing. He asked the right question. So what started happening, we get out to Seattle, and the place that we want to collect is the Washington Park Arboretum. For any of you that have been to Seattle, it's a beautiful, big arboretum. In that arboretum are about 40 eastern hemlocks, ranging from anywhere from being 20 years old to over 80 years old. They're right next to western hemlocks. They both have adelgids on them, and they both have these beetles. And so suddenly, I'm like, this says it all. And I go to the collections managers, a guy named Randall Cunningham, and I say, do you guys treat your trees for hemlock woolly adelgid, or you treat them for pests? And he pulls me aside and he goes, we don't have enough money to mow. Anything that grows here is growing here because it made it, okay? So suddenly I knew something was up. I'm using my farmscaping stuff now with alternate hosts and all this, and I'm seeing, you know what I mean? I'm seeing Carolina, Western, and Eastern hemlocks all in Seattle, all growing fine. Go on to the next slide here. Okay, so what happened? About 2006, the gene jockeys got in here. And I'm sitting in a meeting. This was actually good. They did something really good. They did DNA analysis and they proved scientifically that there are at least 3 strains of the adelgid and one of them's native to our own country. So where's that buzzer? All right? When this guy's talk went off, I'm sitting in there and I almost wet myself because I realized if Western U.S., then what we're looking at there is a stable system that we have in our own country. But nobody knew that, and people questioned it at first. So what happened was, we have this own winter predator, and we also have a summer predator named Scymnus coniferum that I helped to identify, that we just got through the environmental assessment on, and about a month ago got approval for it. But it's the summer predator, because the adelgid has 2 generations, right? So what's one of our farmscaping principles? Bracketing, all right? We had this one. This beetle by itself will control the adelgid in our area because we're up high. Even in sea low, this beetle will control it because you only have about 25 eggs per ovisac. If you get down into this area where it's warmer, the adelgids have 100 eggs per ovisac, and you need that summer predator. So we were lucky.
Summer predator, places like along the river where there isn't a Gulf.
Yes, exactly. Or up on ridges, like up on Horse Ridge and all that.
Because the winter predator needs that duff
Right.
to reproduce. The summer predator doesn't.
Yes, and so we did get the Japanese strain of adelgid, and there is a Chinese strain, and for 20 years we didn't know it, and people were going to Japan and China and, you know, doing all this stuff, and that was all well and good because that's what we knew. But this part of this is teamwork, was to figure all this out, right? So let's go on to the, so what we found out really quickly, go on to the next one, was the first week that I was in Seattle, we worked until 11 o'clock every night, and we dissected 1,200 of those little egg sacs. 600 of them had a Laricobius egg or larvae in them. And another, so that's 50%, and another 45% were disturbed. Okay, so by disturbed, it was an ovisac that had been eaten, and there might be a Laricobius right next to it, but as a scientist, I could not, the scientists won't let you say that it went there. Until I did this UV stuff, and there's orange poop in there now. Boom! I got him! All right? All right. So this is great, man. This is like setting it up, you know, just setting it up. So what happened is, everybody thought that the western trees were resistant. They're not resistant. They have a winter predator, and it turns out if you caged exclusion these, to keep these predators out, western hemlocks die as fast as easterns. So it's obviously they're not resistant, okay? Now there's a bunch of people, yeah, okay? So the first thing we started finding were hemlocks that were planted in 1947. Later on, I went to the Calvary graveyard right above the University of Washington. In 1900, they planted 18 eastern hemlocks that are this big around, beautiful, with adelgids, and I go in there and catch beetles, and I'm like, ha, 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 here it is, okay? So what we believe, and this is becoming more and more confirmed, is that these eastern and Carolina hemlocks are benefiting from these predators, that they're in that natural system. And so that meant to us, if we bring those back here, it's going to work, okay? So let's go on here. Okay, so this is how this little predator works, all right? Here is, if we look at this from a scouting standpoint, none of these ovisacs of the adelgid are disturbed. They're nice and round, little pearls all over the place, okay? And so you see them here, they're real nice. Go to the next slide, okay? This is what it looks like when you have predators. The ovisacs get all torn up, and see how they're torn up? They're torn open. And at first we didn't know how to judge that. Was that a predator? But now using this ultraviolet light, we can show that predators have been in there because there's orange poop. So that really helped us a lot. And so this is one of the ways. It's just like us being out in the garden now. I can walk out in hemlocks and I can flip a limb over and I can tell you whether there's predators there or not. Okay. So here's this beetle. I got 55 of them over there. You don't need to know this is all. That's all entomology geek stuff for torturing students, okay? But this thing is just like less than 1/8 of an inch long, but it does nothing but feed on adelgids. It comes out right now after the adelgid's broken diapause. It's another one of these predators like CMAC that's way more specific than we ever thought that it was. Go to the next slide, okay? Oh, go back one, okay. This thing's native to the Pacific Northwest. It's host specific to hemlock woolly adelgid. It eats other adelgids, but it doesn't reproduce on them. It's synchronized with the life cycle. Every one of these females, if you feed them correctly, right, has a really high egg production, 400 eggs, and it lays from January to May, okay? It lays one egg in an ovisac, and then it marks it. I've never found in the field, I've never found more than one larva in an ovisac. That's how smart, I mean, these things are so smart, okay? They live at least a year, and they cause, in the areas where we've seen them, they cause about a 97% reduction in adelgid. So what happens is you have this patch dynamics going on all the time in Seattle. I'll come in there. This is the first of the season, so I have to go out and scout areas. In some areas where they were really abundant last year, they're not. And in other areas, they're up, okay? So go on ahead to the next one. This just shows that it's synchronized. Don't worry about that. All right, so here's what I was telling you guys is I dissected 1,200. We're working from data. You know, I'm from Missouri, so I like to say, show me the data. I do the science, but I'm doing the science for us, you know, so we get this out there. So 50% of the ovisacs had a Laricobius egg in it. 46% were visibly disturbed, and that's that thing now where we can prove that it's with ultraviolet. Each larva eats 200 to 250 eggs. So they eat tons. Up where we are, they've got to go through 10 ovisacs. So you'll get 100% predation if you have one egg in every 10 ovisacs, because that larva is going to hatch out and eat 20, 20, 20. Just keep going down the limb. Okay, so go on here. So here's what happens. The first thing I started doing was monitoring both eastern and western hemlocks in Seattle. In 2005, here's this hemlock, and it looked like somebody had flocked it. They just sprayed it. It was just white with adelgids, and this is where we had done that study. The very next year, the same time, this branch had 2 ovisacs on it. You can see there's one ovisac here, and there's another ovisac there. That starts the cycle over again. The beetle wiped out 97% of the adelgid, but now the adelgid starts building back up. This is too far dispersed for the beetles to lay eggs, because it has to have ovisacs next to each other, because it usually eats from one into the other. If they're separate like this, they won't lay eggs in there because they go, hey, larva's not going to make it. These females are brilliant, okay? So go on here. So what happened then was this got imported into Virginia Tech. I'm an alum of Virginia Tech. I started hanging out with those guys, and I got the 8th release of beetles out the door, and we put them in Hemlock Hill. Okay, and so we've had studies going on this for a while. All right, so there were beetle releases made all up and down. One of the things that I've been doing recently is I've been working with the Forest Service to evaluate these other release sites, and it turns out that there's beetles in probably more than 50% of them, probably even higher than that. Okay, so really, they're really doing well. Go on to the next. So the other thing that I did, because I was a former regulator, is I wrote the Animal Plant Health Inspection Service and got a letter of jurisdiction, no jurisdiction from them, which said that I could import this beetle. I was going, you know, following the rules. Here's my official permit. And so they gave me this piece of paper, and then I hit the Pacific Northwest catching beetles. Here, look at this. I can catch beetles. Okay, so let's go on. David Mazel was a guy that I worked with. So here's the size of a beetle next to an adelgid, and these are about what the adelgids look like right now. If they have one cast skin, then they're a second instar. So they started out as first instar, cast that skin, and then puffed up wool. And so you see the size of the beetle, it's not that big, okay?